Good day, everyone. I am Maria Julian Campanaro, and today we are going to discuss the Newton's law of gravitation. Use Newton's law of gravitation to infer gravitational force, weight, and acceleration due to gravity. Our objective for the day is first, states who discovered the law of gravity. Second, define what is Newton's law of gravitation and gravitational force. And lastly, give and compute the example of gravitational force using Newton's law of gravitation. Isaac Newton discovered the law of universal gravitation, a fundamental principle in physics that describes how objects attract each other, with a force proportional to their masses and inversely proportional to the square of the distance between them. Newton's law of gravitation statements that any particle of matter in the universe attracts any other with a force, varying directly as the product of the masses and inversely as the square of the distance between them. The formula in getting the law of gravitation is F is equals g constant times m1 times m2 over r squared, where the F is the force of gravity and the g is the gravitational constant, which is 6.67 times 10 raised to the power of negative 11, and the m is the mass of one object, and the m small is equals the mass of the other object, and the r is the distance between the two objects. Now let's proceed. What is gravitational force? The gravitational force is a force that attracts any two objects with mass. We call the gravitational force attractive because it always tries to pull masses together. It never pushes them apart. In fact, every object, including you, is pulling on every other object in the entire universe. The example of gravitational force is calculate the force of gravity that exists between a 6 kg first person and 80 kg second person, who are 50 cm apart from each other. The formula in getting this is F is equals to g times m1 times m2 over the r squared. R given is the mass of the first person is 6 kg, and the mass of the second person m2 is equals 80 kg, and our distance is equals to 0.5. We get the 0.5 meters because we divided the 50 centimeter to 100 to make it the meters. For getting the meters from centimeters to meters, we are going to divide the 50 to 100. So we have the distance r is equals to 0.5 meters, and our gravitational constant is equals to 6.67 times 10 raised to the power of negative 11 m squared over kilogram squared. So we are going to substitute F is equals to 6.67 times 10 raised to the power of negative 11, which is the gravitational force. I mean, the gravitational constant. And times 60, which is the M1, and times it to the 80 kilogram, which is the M2, over the 0.5 squared, which is the distance. And we get the answer of 1.28 times 10 raised to the power of negative 11 Newton. The weight of an object is defined as the force exerted on it by gravity, calculated by the formula W is equals to m times g, where the W is weight and m is the object's mass, and the g is the acceleration due to gravity. This force is what causes an object to have heaviness, and is dependent on the strength of the gravitational field, meaning an object will weigh differently in different locations, such as on the moon versus on Earth. Next example, calculate the force of gravity and the weight of an object of a 25-kilogram block resting on Earth. M is equals to 5.97 times 10 raised to the power of 24 kilogram. The radius of the Earth is 6.38 times 10 raised to the power of raised to the power of 6 meters. Our given is M1 is equals to 25 kilogram and the M2 is equals to 5.97 times 10 raised to the power of 24 kilogram and our radius is 6.38 times 10 raised to the power of 6 meters. Our gravitational constant is equals to 6.67 times 10 raised to the power of negative 11 and m squared over kilogram squared. Find the weight and the force of gravity. First, we are going to find the force of gravity. In, the, in getting the force of gravity, we have to use the formula F is equals to G times M1 times multiplied to M2 over the R squared. Let's substitute it. It's equals to 6.67 times 10 raised to the power of negative 11 times 25 times 5.27 times 10 raised to the power of raised to the power of 24 over the 6.38 times 10 raised to the power of 6 squared is equals to 244.6 Newton. And second is we're going to get the weight. And getting the weight, we must use the formula W is equals to M times G. And we have to substitute 25 kilogram times 9.8 meter per second squared is equals to 245 Newton. Next is acceleration due to gravity. Is the rate at which an object's velocity increases as it falls, caused by the force of gravity, pulling it toward a massive body like Earth. Near Earth's surface, it is approximately 9.8 meter per second squared. This means a falling object's speed increases by 9.8 meter per second 9 every second, assuming no air resistance. The symbol of acceleration due to gravity is g. To calculate acceleration due to gravity using the formula, g is equals to g times m over the r squared. So, our sample problem here is calculating the G and Venus. Our problem, the mass of Venus is 4.87 times 10 raised to the power of 24 kilogram, and its radius is 6.05 times 10 raised to the power of 6 meters. Calculate the acceleration due to gravity on the surface of Venus. The gravitational constant G is 6.67 times 10 raised to the power of negative 11 and m squared over kilogram squared. Solution: the given values are identified. M is equals to 4.87 times 10 raised to the power of 24 kilogram, and our radius is 6.05 times 10 raised to the power of 6 meters. And G is equals to 6.67 times 10 raised to the power of negative 11 and m squared over kilogram squared. The formula for acceleration due to gravity, G is equals to gm over the r squared is used. The values are substituted into the formula. G is equals to 6.67 times 10 raised to the power of negative 11 and m squared over kilogram squared times 4.87 times 10 raised to the power of 24 kilogram over the 6.05 times 10 raised to the power of 6 squared. The calculation is performed. G is equals to 3.248 times 10 raised to the power of 14 and m squared over the kilogram is equals to over 3.66 times 10 raised to the power of 13 m squared. The result is obtained to g is equals to 8.87 meter per second squared. Our final answer. The acceleration due to gravity in the surface of Venus is approximately 8.87 meter per second squared. And that's all. Thank you for watching.